YouTube channel. Today we'll be discussing differentiation, but we'll focus our attention on quotient rule. Unlike in our last class, in our last video, we were able to discuss product rule. Product rule is multiplication rule, but this time around we'll be discussing quotient rule. Quotient rule is like a division rule. As you can see on the screen, when y equals u over v and u and v are both functions of x, then dy dx equals v du dx minus u dv dx all over v squared. It's as simple as that. So how will you know if a question is a quotient rule? It's very simple. As you can see, this question now is a division question, and you apply a quotient rule. You have up and down, denominator, numerator, and denominator. So whenever you see a question of this nature, you are going to apply quotient rule. You are still going to use some idea from our product rule. We have some standard derivative that we're able to iron out. If you have not seen that video, kindly check our YouTube channel on differentiation product rule. So we have a question here. Let's dive straight into solving the question. The question says we should differentiate y equals 4 sine 5x all over 5x raised to power 4. It is very simple. Don't forget, in our earlier explanation, we say whenever you have y equals u over v, that's what we have here. Y equals u over v. That means all what you have here, you represent it with u, and all what you have here, you represent it with what? V. Then you iron out your issue. Awesome. So let's see solution. So now see, because what you have up is u and what you have down is v. So let u equals 4 sine 5x and let v equals 5s raised to power 4. Awesome. So with this, we can now iron out our issue. And don't forget that our dy dx is what we have here. That will guide us. Great. With this, it's going to guide us. Now, we know our v already, so let's get our du dx. We know our v is here. So let's get our du dx. We can only get du dx from u. So let's go get our u. Awesome. Now, this is our u. To get our du dx, that means we are going to differentiate 4 sine 5x. Now, if you remember, in our last video, we explained some basic derivative. For example, we say if sine ax, if you differentiate sine ax, it will be what? A cos ax. If you differentiate sine ax, it will give us what? A cos ax. In the same vein, if you have this, because we have 4 sine 5x now, so for us to differentiate, you can say 4 sine 5x. Awesome. So if you have to differentiate this sine 5x, now it's going to give us what? 5 cos 5x. Because if sine ax can give us a cos ax, that means sine 5x will give us what? 5 cos 5x. That's the meaning. So you can check out our video on product rule. We're able to iron out these standard derivatives. So since we will not differentiate this, let's just leave it as our u here. Now if you are now differentiating this du dx, now this 4 is here, so we say sine 5x will give us what? 5. We are differentiating now cos 5x, because we are actually differentiating. Awesome. So if you are now multiplying this 4 times 5 to give you 20. 4 times 5 will give you 20. So you can now put 20 cos 5x that you have here. Awesome. So you've been able to, now in your formula you have u, which you have here, 4 sine 5x. You have du dx now. This is the du dx, which is 20 cos 5x. Okay. Let's now deal with v. Our v is 5s raised to power 4. Now let's differentiate the v dx, because we are going to need it in our formula. Okay. Awesome. So our dv dx, our normal differentiation this time around, you bring your power back, then you minus 1 from it. You bring your power back. What's our power this time around? Our power is 4. We are bringing it back. We are bringing our power back. Then we bring out this. Then you can minus 1 from the power as usual. That means we are already differentiating. Awesome. So if you say 4 times 5 here will give us what? 20. If we are multiplying these together, you have 20. Then if you minus 1, 4 minus 1 here to give us 3. Awesome. So our dv dx will now be 20x raised to power 3. So having gotten all our 4 parameters that we need, so let's insert them into our formula to get our dy dx. Very easy. You get them one after the other. Beautiful. Now, what is our v? Check. Our v is this 5s raised to power 4. So insert it. Beautiful. What's our du dx? We've been able to iron it out. Du dx. This is du dx. 20 cos 5x. Our du dx is what? 20 cos 5x. Awesome. The next one is our u. What's our u? Our u is here. This is our u. 4 sine 5x. Our u is 4 sine 5x. So we use our u here. 4 sine 5x. That's our u. 4 sine 5x. Awesome. So the last one here is our dv dx. What's our, okay, this is our dv dx. 20s raised to power 3. Awesome. Now at the base here we have v squared. What's our v? You just put the square here. What's our v? Our v is this 5s raised to power 4. Our x is what? 5s raised to power 4. That's our v. So we just insert our v here. Our v is 5s raised to power 4. So we have it here. Awesome. Then you close the bracket. Beautiful. So we've been able to insert all our value correctly, one after the other. You can always pause and rewind the video to get the explanation again and again. Beautiful. So with this, let's quickly see what we can do. Now let's first of all work with what we have as the denominator so that we won't get ourselves confused. This 5x raised to power 4 raised to power 2. Now what we have here, this square here is meant for everything that is inside here. It's meant for this 5 and it's also meant for this s raised to power 4. So if you say 5 square will definitely give us 25, and we're already working with this square here. Then s raised to power 4 multiplied by these two is going to give us s raised to power 8. Awesome. That means we've been able to iron out this, so we'll be left with 25s raised to power 8. 25s raised to power 8. That's what we'll be left with. 25s raised to power 8. Beautiful. So we've been able to use this square to multiply what we have here. So 5 square, then s raised to power 4 square. Beautiful. So having done that, so let's see how we can open up all these brackets that we have here. Beautiful. So now let's just multiply all what we have here. You see, you can just multiply all. So if you say 5 times 20 here will give you what? 100. Let's do it one after the other, one at a time. 100. That means you have multiplied this 20 out. So this 5 times 20 here is 100. This s raised to power 4, this is it. This is cos 5x. That means you've been able to iron out this. 100x raised to power 4 cos 5x. In the same vein, just say this 20 times 4 here will give you 80. 20 times 4 here will give you 80. That means this 4 has gone. So you are left with 80 s cubed sine 5x. Okay, let's just rearrange this. Sine 5x. So that this one has gone to the front. Beautiful. So if you just multiply this 20 times 4 here will give you 80. This s cube is here. This sine 5x is here. So it's just for you to multiply all what you have here. And you have what you have here, 100s raised to power 4 cos 5x minus 80s raised to power 3 sine 5x all over 25x raised to power 8. It's just as simple as that. It's just for you to bring all your parameters that you have been able to get out. You'll be able to get them out one by one. Your u, your dv dx, your v, your dv dx, your du dx, you've been able to get them one after the other. V du dx, u dv dx, then your v, just square it. So just follow the principle, you'll be able to tackle any question, no matter how complex they are. So the next thing now for us, depending on how you actually want to leave your answer. Now, look at this. Something is common at this numerator up here. We can just factorize something out. We can say 20, we can bring out 20x, okay, this is 100x4, this is 80x3. That means we have more than x3 here. So we can bring out 20 here, we can bring out 20 here, we can bring out s3 here, we can bring out s3 here. So let's quickly do that. Beautiful. So it's just like we are factorizing. It's just like we are factorizing. Okay. So if you bring out 20s cube here, what will be left from this right hand side? If you bring out 20 here, we'll be left with what? Like 5, because if you say 20 times 5 will give you 100. We'll be left with 5. Awesome. Because 5x. So that's what we have here. But you know, we have taken out s cube here. So we'll still be left with 1x. Awesome. Don't forget, we took out 20 because it's common to both sides, and we took out x3 because it's common to both sides. So if you now say, like, if you multiply this and this, you will still get back this. So 20s cube is common to here, is common to here. So what will be left from this side if you remove 20? You'll be left with 5 and x, because we actually have x raised to power 4 here. If you are removing x raised to power 3, we still have 1x, so cos 5x that we have here. Now we have taken out 20 here. The implication will be left with what? We have taken out 20s cube. 20s cube. That means we'll be left with just 4 here. This s cube has gone out. We'll be left with 4. So we'll be left with 4 sine 5x. Awesome. Beautiful. Because if you multiply, if you open up this bracket, you will still get this. You say 20s cube times 5x, you get 100x4 cos 5x, that is here. 20s cube times 4 will give you 80s cube. You now have sine 5x all over 25x raised to power 8. Beautiful. So with this, let's see what we can do again. Awesome. Now, looking at this, what can we do? What can we do? Okay. Let's bring these two together because they look alike. Let's get the template here. Beautiful. Because they look alike, let's bring this here. Beautiful. And let's bring this here. Beautiful. That means we've been able to awesome. We've been able to separate this from this. Awesome. So it is still the same thing. It's just like saying 20s raised to power 3 divided by 25s raised to power 8. That's what we have here. Then you have all this 5x cos 5x. We have it here 5x cos 5x minus 4 sine 5x. We have it here 4 sine 5x. It's just as simple as that. You can also leave your answer like this, or if you feel like solving further, you can cut. Something can cut out from up and down here. Let's quickly see how we can manipulate that. Okay, 5 can go here, and at the same time 5 can go here as well. Beautiful. So 5 can go here, 5 can go here. So if you use 5 to divide what we have here, 5 in 20 will be left with 4. 5 in 25 will be left with what? 5. Will be left with 5. Beautiful. Awesome. What can cut again? Okay, this x can still cut themselves out. We have x cube here. That's x into 3 places. We have x into 8 places here. So if you remove this x into 3 places from here, from this x into 8 places, we'll be left with x into 5 places at the denominator. That means this x into 3 places has gone. We'll be left with what? With 4 here. We'll be left with 4 here. Now x into 8 places, if we remove x into 3 places, we'll be left with what? X into 5 places here. Beautiful. So this is our final answer. 4 over 5x raised to power 5. 5x cos 5x minus 4 sin 5x. It is very easy and straightforward. You can always pause, rewind this video for better clarification and understanding. Kindly drop a comment with us if you have any issue with any of our video or this particular video, or if you have any question. Kindly help like this video, and don't forget to subscribe to this YouTube channel, My Simple Maths, and help press the notification bell so that you can always receive notification from us whenever we post a new video. Thank you.